Alright, Brandon Clayton here, the Algebra Guy. In today's lesson, write systems, given a table, graph, or a verbal description. Now, for the most part on the test, you're going to be given a verbal description, so we're going to spend quite a bit of time using those as stimuli. What's the TEAK? 2I, write systems of two linear equations, given a table of values, graph, and verbal description, just as a title suggested. How do we translate from a verbal to a system? So here's some steps that I want you to consider every time. So 4 things. We're going to read the problem, make sure all the words and ideas are understood. Sometimes it's okay, and oftentimes I do this as well. Read it 2 or 3 times to say, what are they saying? Okay, then start pulling out your information. And identify what we are looking for. So what's the question asking? What do they want? They don't want the cost or the number of shirts, or just figure out specifically what they want. Name what we're looking for. Choose some variable to represent the quantities. This is just telling us to choose a variable, make it X or Y. That way we know how to refer back to it when we're coming up with an equation. Now we're going to translate into a system of equations. So going back to that variable description, we're going to use those same variables and translate into equation. So let's start. All right, so our first problem sounds like this. The sum of two numbers is -14. One number is 4 less than the other. Find the numbers. So we read the problem. I understood what they're asking for. I understood the words and vocabulary. The sum is, we're talking about adding something. This is adding. For -14. Yes, I understand all this. One number is 4 less than the other. And so we're looking for, so I got that part. So what are we looking for? We're looking for two numbers. Let's give those a name. So we're going to call X one of the numbers. So let's just say one number or a number. And I usually wouldn't write this out, so it seems kind of funny, but to say a number, and Y is going to be the other number. It's not that sophisticated. So the other number is going to be Y. Now let's go back and let's translate this into some kind of equation, in particular a system of equation that as represented by this variable. So the sum of two numbers is -14. How can we use these variables to represent that sentence? The sum of two numbers. Well, we got two numbers here represented by X and Y. We don't know what they are, but we do know that the sum of those two is, so this is always going to be my equals, is -14. Remember, we want a system of equations, so there's another equation we need to consider as well in order to find this answer. One number is 4 less than the other. Now, does it matter which one? No, it just says one number is 4 less than the other. So we're going to take this first number. One number is 4 less than the other number. So that's how you could write it, just like this. One number is 4 less than the other number. Now notice I put less than after the Y, because that's the proper way to write it, right? Because this number minus 4. We don't want to say -4 plus the Y. So this is the proper way to do it. Now you'll often see me write these brackets because normally, or oftentimes when representing a system, this brackets will be included to say that these two are being considered together. All right, let's go to our next problem. A married couple together earns $110,000 a year. The wife earns $16,000 less than twice what her husband earns. What does the husband earn? So we read the problem. I understood the question and the vocabulary that's included there. Now, what are we looking for? We want to know how much does the husband earn. So what are the two variables we're talking about? We're talking about how much the wife earns and how much the husband earns. So actually, let me do it this way. Let's make wife W equal the amount the wife makes. So some money amount that the wife makes, and of course my H is going to be some dollar amount that the husband makes. So that's the question, what does the husband earn? So let's start back with our sentence again. A married couple together earns $110,000. So how could we represent an equation that will illustrate that sentence? Well, together is giving me the idea of them being added. So W, the wife's earnings, plus the husband's earnings is going to equal 110,000. Notice I spoke exactly what that W is represented. The wife earnings and the husband earnings. So it's not talking about how many wives or how many husbands or how much they weigh. I have to say, this is how much she makes, this is how much he makes, this is how much they make together. So this sentence makes sense. Now, what else can we include? The wife earns 16,000 less. So the wife is 16,000 less. See, notice I put the less after something, or after less than what? Twice her husband. So 2 times her husband. What does a husband earn? So from this, we can now come up with an answer for how much the wife earns and how much the husband earns by solving this system. But we're not going to solve any systems in this lesson. We just want to know how to set them up. And to be honest with you, that's the hardest part, is setting them up. The easiest part, because I'm going to show you how to do it a couple of different ways, including using the calculator. Once you have it set up like this, is pretty easy. But thinking through how it's set up can be the toughest part. So I want to take our time on this. Devin is 26 years older than his son Cooper. The sum of their ages is 50. Find their ages. So what are we looking for? So we read the problem here. We asking the question now, what are we looking for? So we're looking for their ages. So how old? So we're going to let D represent Devin's age, and C represent Cooper's age. Cooper's age. All right. Just want to make a note. Normally in the STAR test, they're going to tell you the variables, by the way, because it's multiple choice. So they're going to have to show you all this. So we're coming up with them, but you're going to be that's going to be provided to you. So now we've identified some variables to represent what we're looking for. Now let's put it into an equation. Devin's age is represented by D. Is my equal sign. 26 years older. So 26 years older than what? His son Cooper. And there it is. Devin is 26 years older than Cooper. Devin is Cooper plus 26. Either way you want to say it. Now I didn't have to put the 26 second on this one because addition is commutative, which means I can switch places. They're going to be the same answer. But I wanted to remain consistent in how we were setting this up. Now, what else do we know? That the sum of their ages is 50. So how do I do that? Well, I know it's saying that Devin's age plus Cooper's age is 50. The sum of their ages is equal to 50. So they're saying the same thing. Cooper and David are going to add up to 50. And it didn't matter which one I put first because addition is commutative. All right, so that would be the system that I would use to identify their current ages. All right, a lot of words here. When Jenna spent 10 minutes on an elliptical trainer and then did circuit training for 20 minutes, her fitness app says she burned 270 calories. Now, what I would do, honestly, with a sentence paragraph that's this big, is I'm going to go straight down to the question, because you'll get to reading and not really understand what you're looking for. So what are we looking for? So we're looking for the number of calories she burned on the elliptical trainer and the number of calories she burned on the circuit. So now I know which two pieces we're talking about. So we're talking about I wanted to keep that. So we're talking about two things, the elliptical and the circuit. So I'm going to call the E the number of calories for the elliptical, and C the number of calories burned on the circuit. So don't feel like you have to read through the whole paragraph and then start. Sometimes you may just go straight to the question, like, hold on, what am I looking for first before I start to answer this? So now I know what I'm looking for. I see what they're doing. I see the two variables that we're going to be comparing, so I can start thinking through that. When Jenna spent 10 minutes on elliptical trainer and did circuit training for 20 minutes, her fitness app says she burned 278 calories. When she did 20 minutes on the elliptical and 30 minutes on circuit training, she burned 473. How many calories does she burn for each minute on the elliptical training, and how many does she burn each minute for the circuit training? So let's take what we got. So we read it, we've identified the question, and we gave some variables for it. So let's set this up. 10 minutes on the elliptical training. So 10 times E, which is our elliptical trainer. So I got 10 times E, the number of calories she's burning for the elliptical training, plus 20 times C, the number 20 times her circuit training is it gave her 278 calories. So we're all looking at calories in this, and actually both of these. And for the second time, she had 20 E, because 20 minutes on the elliptical plus 30 minutes on the circuit, they give us 473 calories. So I will use this system to find out how many calories did she burn for each one. So that's how you set that up. All right, you also might see it this way. We talked about tables, right? So this is actually set up as a system, and this is pretty simple, but if you hadn't seen it before, it may throw you off a little bit. So let me point out what this is. This looks like. So this X, we have an X value here, and then we have some Y values here, and then we have some other Y values. So what you're really looking at is two sets of equations. Here is one set X in F1, and then another set X in F2. These X's correspond to both of those equations, but they have different sets of Y values. So you want to look at them one at a time. So how do we come up with the equations that go with these? Well, let's start with just these two. Let's start with this and this one. All right, so I'm going to use this X's, and actually let me rewrite this. That'll make it easier. -6, -3. Let's put my X here, and we'll put Y1, because that's our. I'll keep the same letter. So we'll do F1. -6, 6, 0, 2, -3, 4. Sorry about that for skipping that. 3, 0, 6, -2. Now I don't need all of these. I just need two of them, because I know that's a line. So I want the equation here. So how do I get the equation? Let's find the slope first. I don't want to use those, actually. I want to use these. These look a lot easier. So this is going down 2, up 3. So I know my slope is going to be Y equals -2 over 3x. My y-intercept is anywhere where x is 0. So my x is 0 right here, so I have it at 2. So that's pretty easy because they gave us the y-intercept. I didn't have to figure it out. So now I want to find my second equation. Alright, for my second equation, I'm going to use the same x's. Actually, I'm going to draw another one over here. Let's call this F2. I'm using my same x's, -6, -3, 0, 3, 6. And corresponding 10, 4, -2, -8, and -14. So I'm going to pick any 2 points here to get my slope and actually to find the equation of this line. I'm going to choose maybe these two. It doesn't matter. They're going to give me the same answers. So 4 to -2, we're going down 6 here, and -3 to 0, we're going up 3. So -6 over 3 simplifies to -2. So y equals -2x. So I know what my slope is. Now I need to find the y-intercept. How do I find the y-intercept? I can solve for b. So put some point in and solve for b. So I'm running out of space here. So let's see. I'll use this spot here. So I know that my y-intercept is any place where my x is going to be equal to 0. but I don't know what that is. So what I'm going to do is put at least 1 point in. So I'm going to use this equation. Actually, I'll continue with this. So I'm going to say that I'm looking for my b. I'm going to plug 1 point in. So let's take one of the points from here. And 0, -2 looks pretty easy. So let's use that one. So in place of y, I'm going to put -2. Then -2 times my x is going to be the 0 here plus b. And I didn't realize that. I already got it. So b equals -2. So now I know my equation is just going to be b equals -2. So this is all my two equations. I'll stick it up here. -2x minus 2. So these are my two equations right here. So that took me a little longer just because I didn't see that the 0 is right here already. So it's already, so I said it and everything, but there it is. So those are my two equations. They may write them in standard form or leave it this way, but no, that's how you can take a table and get those equations. So let me do this one as well. We got these, and I'm going to save a little bit more space on this one. So I know that let's do this first one. So let's call this my F. I better not do that. So we'll just call it my Y. This will be my yellow, and we'll make this my blue. All right, so what's my slope for this one? Let's take any 2 points. We'll use 2 and -3. So it's going down 5 and up 1. So that'll be -5, because -5 over 1 is -5. And my y-intercept is anywhere where x equals 0. X equals 0 right here, so I have a -3. And now for my next equation, y equals, what's my slope here? So my slope is, let's take any of these. These are pretty simple, right? So all of these look pretty easy. I'm just going to take 1 and 0. So from 1 to 0, we're going down 1. And then the x that corresponds to this one is here. So this one's going up 1. So what's -1 over 1 going to give me? Let's just -1. So I know I have a slope of -1x, and actually we don't write 1 usually. So let me just keep it -x. And my y-intercept is anywhere my x is 0. So here it is right here. When my x is 0, my y is 1. So I know I have a 1. So that's how we use the table. I didn't split it up both physically just to save space and time, but you can see that we have two equations in here, keeping the same, using the same x values from that table. All right, how does it show up on STAR? Here's one way for using a graph. They're going to ask you to identify the equations that correspond to this graph. Now this is simple, just like linear, without two lines. You can just take one line at a time to figure this out. Notice that all of them are in standard form. It takes a little bit more work because you can't just solve these equations in slope-intercept form. You have to put them in standard form after that. So what I'm going to do, and also another way you could do it, just put all these in the calculator. Like if you completely forget or need another way of checking it, put them all in the calculator and see which graphs come out to be the same one. Now I'm not going to do that for time's sake, is go through each one and put it in the calculator. I want to show you how to actually work it. But so I'm going to take this K1 first, and I'm going to find 2 points. Let's see here, 2 points. And sometimes it's tough to make sure you get a really good point that is going through an integer. So let's see, is that a good point? And to know if I have a good point, they should continue at the same rate. So this is going down 3 over 1. 1, 2, 3, 1. Yep, so that looks good right there. Notice it's going down 3. 1, 2, 3, 1. So that means that this is the right slope. This is a -3. So for my K1, I'm going to write my equation here. So I know we have a slope of 3x because it's going up 3 over 1. So 3 over 1 is just 3. What's my y-intercept? Well, it intercepts right here at -2, so there it is. All right, for my K2, what do we have? So we have a y-intercept of 4. Yay, that makes that so much easier. And what is our slope? So let's get some points. This looks for sure like a good point. This one doesn't look great. Maybe here. So let's look and see if they're consistent. Did I say here? I think they're, yeah. 1, 2, 3, 4. And then from -9 to 0 is 9. So yeah, 4 to 9. So it looks like it's going 4, down 4 to the right 9. So -4 over 9x, and the y-intercept's at 4. So those are my two equations. Now I want to put these in standard form. So putting this in standard form, this first one, all right, I accidentally erased that, so let me just do it this way. This might be better. So I subtract 3x on both sides because I want to get this in standard form again. -3x plus y equals -2. I'm going to multiply by -1 on both sides. So that changes this -3 to a positive 3x. -1 times y is a -1. And -2 times -1 is 2. So just from this part here, I have one of the equations. I can kind of glance over here because I know this is the same thing as what we just came up with for our K1. Which one of these has a 3x minus 1 equals 2? 3x minus 1 equals 2. So we're good here. 3x minus 1. And nothing else has it. So I'm already knowing that this is likely the answer. If I solve this one if I put a 0 here for an x-intercept, that'll be 9 times 4, so I know I have a 0, 4 as one of my points. And if I put a 0 here, I know I have a 9, so 9, 0, 9, 0. So I can see that 9, 0 and 4, 0 here. So this is already checking out to be great. I'm going to go ahead and work it in case it doesn't work out like that on your test. But that's how I would do it. I would go ahead and solve one and look over there and see if that helps me at all. For time's sake. All right, now I want to get this x to the left, so it's in standard form. So I need to add a 4 ninths. Actually, before I do that, I want to go ahead and get rid of this fraction because I know I can't have this fraction here. So I'm gonna multiply both sides by 9. Multiply all this by 9. So multiply this side by 9. Multiply this side by 9. 9 times y is 9y. Equals 9 times, these 9s are going to cancel and leave me with a -4x plus 36. Now I need to get my x on this side by adding 4x. And that leaves me with 4x plus 9y equals, this goes away, 36. 4x plus 9y equals 36. That's what we got. Next problem. All right, sports magazine. Oh my goodness, this is a long one, right? So when I have this long one again, I'm gonna go straight to the bottom and say, what do you guys want from me? Which system of equation can be used to find S, the number of pages in a sports magazine, and T, the number in pages in the issue of technology? So I know my S and T. They've already defined it for me. You can rewrite it if you need to. But I'm not going to do so here. So the sports magazine prints 12 issues per year. Remember, know that an issue is like just a magazine. So in that magazine, there's a number of pages, obviously. And a technology magazine prints 10 issues per year. The total number of pages in all the issues of sports magazines for 1 year is 32 more than the total number of pages in all the issues of technology magazine for 1 year. So that's a mouthful there. So what can we do to get that started? Actually, let me go ahead and finish. We got one more sentence. Each issue of the sports magazine has 18 fewer pages than each issue of the technology magazine. So let's start this way. We know that, let's take that last sentence. That seems pretty straightforward. Each issue of the sports magazine, we're talking about pages of the sports magazine. So the sports magazine has, or is, 18 fewer pages. 18 fewer pages than what? Than the technology. So that's one of my equations. And if I glance over here, I see that I have it here and here. Nope, this isn't right. So I can see that B and D can be it just from getting that first equation. Now, what's my next one? We have the total number of pages in all the issues of sports magazine for 1 year is 32 more of all the pages in sports magazine. So this, all the pages in sports magazine And remember, there's 12 issues per year, so I have to keep that in mind. We're talking about the number of sports magazines. 12 issues per year is going to be the same thing. For 1 year is 32 more, so plus 32 more than in technology. Well, how many issues do they have a year? Well, they have 10 a year. So that's 10 a year. So because on that first sentence we're talking, well, this sentence right here, we're talking about the number of pages for the issues. Well, we can't just say one issue. We know there's 12 issues per year, 10 issues per year, and we know there's 32 total more for the sports than it is this technology. So that's the one we want, and this is obviously the right answer there. All right, the owner of a clothing store buys T-shirts for C dollars each and sells them for P dollars each. Last month, she bought 600 T-shirts and sold them 500 of them and made a profit of $2,800. This month, she bought 400 T-shirts and sold them and made a profit of $2,400. Which system of equations can be used to determine the value of C and P? So what is C and P again? Let's remind ourselves. C is how much the cost is, how much he's buying them for. And P is going to be how much he's selling them for. P is profit. So this is like my cost, and this is my profit. And so we're putting the C's and the P's together to get some number at the end, some kind of profit at the end. So how do we set this up? Last month she bought 600 T's. So she bought 600 T's, that's the cost. So that's my C. I know at the end this is going to equal, what did they say, 2,800. So this is 600. And sold them for 500. Now we ended up making a profit. So how's that working out? So we need to take our 500 P and subtract the cost. And after we took away the cost of the shirts, there ended up being a profit. Now this looks deceptive because you want to put that 500 after the 600 because the 500 is smaller, especially when you're subtracting. But when you think about the problem itself, you realize, hold on, our profit has to be bigger when we subtract away from the cost to get this 2,800. So if we put it after there, we're going to have we'll still end up with the same thing. It'll be plus this, but it's better to start with the profit when you subtract. It's just easier to think about, but you would end up with the same thing because this is going to be negative 600 C plus 500 P, which is going to add up to the same thing. All right, so the next sentence we got is she bought 400 shirts. So she bought, this was the cost, 400, and sold them all. So she sold all of them. So she sold all of them. That's how many she sold, and she ended up making $2,400. So that's what that looks like. So which equation represented by this one? 500P minus 600C, 500P minus 600C. This is good, and this is good. I think that's the only one that's close. Make sure I got that right. PC. And these are the numbers here are so similar. You got to watch them carefully. Like these two look so similar, but I noticed that this 600 is not supposed to be. It's supposed to be 500. While that's tempting, look, 600 minus 500. You want to do that in your head, but that's not the right answer. So our only answer here is going to be A, as it should be. There are 9 books stacked on a shelf. The thickness of each book is either 1 inch or 2 inches. The height of the stack of 9 books is 14. Which system of equation can be used to determine X, the number of 1-inch books on the stack, and the number of 2-inch books on the stack? All right, so X is my number of 1-inch books, and Y is my number of 2-inch books. I know there's a total of, so this is the number of books, right? Remember, X and Y is a number of books. I know there's a total of X plus Y equals 9. There's a total of 9 books. So that's one equation I can use. So that's not going to work, and that's not going to work. So you just getting a piece of it is often really beneficial. So I know it's one of these two. So what about the height? So this is looking at the number of books here. What about the height of the books? Well, I know the total height is 14. The X's are just 1, so that's 1X, plus 2 inches for every Y. And this is the equation I want to put together to finish my system. So which one is this one? Looks like it's going to be this here. not that one for that reason. All right, let's go to our next one. Oh, we're done. Fantastic. Hey guys, I know that was a little bit, but that is what we mean by writing system of equations. I'm going to reiterate that it's important that you know how to write them, even more than solve them, because setting them up, as you can see, takes a little bit of thinking and strategy, if you will, but you just take one piece at a time. That's the most important part. I'll show you later how to use a calculator to solve these as well as do them by hand. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.